What's up, guys? Shamar here again, and in this video, I'm going to cover something a little bit different. This video is going to be a little bit faster from the previous video I did for the flowchart because that was pretty long. I was just it wasn't as organized as I would like it to be, so I'll try to make this one a little more concise about explaining what's happening. The code for this one's on GitHub already. So you go to FinToCoder, algorithm workouts 2021, algorithm 2, compressed array. Um, and also the other algorithm is here from the previous video, flowchart algorithm as well. Um, okay, so let me go back. Okay, so this video basically, well, I explained it in the video before this, how we're going to basically compress um, arrays of primitive types to basically um, be more efficient, and we want to make a library to help us do that. Um, so first, I'm going to start by um, creating a header file. So let me go over here, right click, add new item. I'm going to do header file. I'm going to call this, you can call this what you want. I'm going to call this compressed array. Okay. And so I'm just going to basically bring them in and talk about what each one of these do. So I'll bring these in. So we're going to do a namespace. You can name this what you want. This namespace is similar to like the standard library namespace in terms of like how it'll be implemented. And inside of a namespace, we're going to put a class. So I'm going to call this class compressed array. Okay. So now we need to define the methods that we want the class to have that we can use when we implement it. So basically, you're going to just bring these two in. So basically, how this works is it checks for which primitive type between integers and chars. Um, so which of those two is being passed in. And basically, we're going to take those values and compress them based off the number of times they repeat. So let's bring in our constructor and destructor here. Something simple. We're just going to clear the vector. Okay, so let me explain this one here. This is our template function. Now, this allows us to take in any type or any class. You could also use class here if you want, um, but I use type name here. They essentially do the same thing. I can type, pun intended. And so basically, this is a template function. This allows us to take in any type. So this could be int, this could be a char, this could be anything. And so I called it T because that's like the standard naming convention you see when people do template functions in C++. Um, so basically, it doesn't return anything, and this simply is the function that um, we use to compress the primitive array types. And so we take in an array of type T, and we take in the array size. So if it's a type that we don't have defined, we're going to say this type is not compatible. Now, first let me bring in the two types that we're checking for, integer as well as chars. So you can see here we leave this blank and we define integer. So we explicitly define integer as one of the types, and we change this t to integer. So for instance, if we change this over here to char, you can see there's no definition for this one, right? Matches the specified type. So these functions have to match up. The only thing that we can change is this parameter here. Okay. So am I recording? Okay. All right. So next we want to check if the array is greater than 1, meaning that the array is pretty much has something to compress. Because if there's not at least two elements, then it'll be more inefficient to compress it um, rather than leave it in its current state. So if it's less than at least two elements, what we're going to do is simply say nothing to compress. Oops, grab that again. So we're going to say nothing to compress. Let me include IO stream here. Okay. And so if it is at least two elements, first we're going to clear the vector if they decide to compress more than once. We also have to define the type. So because this is an integer, I decided to go with I for the type, and this is just for decompression. And so let me just bring in these variables here. Okay, so we start off with the repeat counter being 1 for the first element. The current character, now don't be confused, this doesn't mean char, this is just the current character, whether it's an int, whether it's a char, boolean, um, basically just anything, any one of those three types. Um, Basically, we just grab the first element, and then the last element flag will be set to false, and last index first time will be set to true. I'll explain this one in a minute. So, so basically, we start off by saying, first, let me just put this here. So we basically say if the last index is first time, we repeat the counter, or we decrement the repeat counter by 1. And so the last index first time essentially is when you're on the last iteration, when I is like basically at the last element of the array. We don't want there to be an extra value appended on because how we check it, it'll duplicate, and you'll see that in a minute. And so we just decrement it by 1 before we run the final compression. So first, let's start with this one. So this is basically if it's greater than 2. So if we have an element that repeats more than 2 times, then we basically we want it to be element underscore amount. And so that's basically what this does. So we set the string, we take the current integer, because remember this is the integer function, and we basically change it to a string. Then we append it to our vector, and then we set the current character that we just appended now to the new index, because remember, up here, we're going to say if it's not equal, meaning that this if branch didn't get triggered, and it's not the first element, and it's not the last element, then basically we want to come here and we want to actually set it as well as the repeat count of how many times it occurred. We want that information. So we come here because it occurred more than 2 times. And then basically the last index first time for the duplicate, we essentially just explicitly compress it, and then we break the while loop. And this is just basically an edge case that I found while I was testing it. There's definitely ways to optimize this, but this basically is just for an edge case here. Especially when you're making libraries for other developers, you definitely will want to test edge cases on your code to make sure that it works properly. And so now if it's greater than 1, we do the same thing, meaning it's 2 essentially. Um, so basically if it's only 2, do, what did I say up here? Element underscore. So now, instead of just printing, and the reason why I did it this way was because, okay, so if you have two integers, that's 8 bytes. Well, we can't really compress that, but it does occur. So we needed a way to account for that. So the element here, essentially, this element here, for example, if we have a 1, okay, well, this one character, which is going to be converted to a string, that's 4 bytes, and then this underscore is 4 bytes. Therefore, we use the same number of bytes as the original array if it repeats twice. Now, that's not efficient, but nevertheless, there could be repeats of 3 or 4. So as long as we don't actually give away efficiency, it still does its job. Okay, and then everything else is the exact same. And so now this case here was just for the very first index. Like I said, this could be optimized. Um, this is for the very first index. This basically just explicitly converts to a string, this integer to a string, and pushes it to our vector, and then we set um, the next index item in the array to our current character, and we set the repeat count to 0 instead of 1. And this is because this is our first element. Um, wait a minute. And we increment I here. Okay. Yep. And in every other case, we increment I afterwards, but in this case, we increment it first so that we move on to the next character. And our last case here is to simply, if it's at least 1, but it's not 2, and it's not greater than 2, and we just simply do element by itself. We don't do the underscore. So now we're only using 4 bytes. So therefore, we're not giving away efficiency, but we're not taking away efficiency either. We're not giving away efficiency, but at the same time, we're not like improving or optimizing pretty much. It's the same number of bytes. Okay. And so now we simply would do the same for um well first let me bring this in here. This is for debugging purposes here. Uh where are we? Yep, so the outside of here. That's for debugging purposes. We just loop through each item and print it. And so now let's do the same for the char function. I'm just going to paste it in. This can really be optimized. So for instance, there's only one difference here, and that difference is right here. Basically set this to a char instead of an integer. That's the only difference. We could essentially put it in here, and we could say, and we could check for type explicitly in here, and based off that type, we could set this, or we could pass this information into this function here instead of duplicating that code. That's one way to optimize it. Um, Nevertheless, it's the exact same thing. Oh, and the type is obviously different here too, which we could also explicitly put inside of this function here. So next, I want to decompress. So um, I'll just hit go through each line here and explain it. Okay, so it's the same as above. We define type T, and we return an array of T, so the pointer to an array of T objects, and we named it decompress. Okay, and so for our variables here, we just simply have the element count as well as the current position, and we set those both to 0. And so for the very first for loop, we're simply just uh, finding the amount of elements total. And we essentially do this by, um, if it's only two elements, so basically we start at the first element for the size of the vector. We find the underscore. Again, this could be more optimized. You could define a macro and change it to whatever character of your liking, based off whatever you plan for users to use it for. I just chose the underscore. Um, and so we find the underscore. And if it's not at, if it's actually at a pointer, meaning it exists, then basically we want to find it again and we want to check that it's not at the end. Because remember, the way that I had it set up is the underscore means that there's only two elements that repeat. I mean, the element only repeats twice. If it repeats more than twice, then it actually has the number next to it, which is three characters, which is 12 bytes, which is like the lowest you could get for or for three or more, obviously. And then for two or more, it's equal as well as if it's only one. And so here we check that it's not at the end. That means it's three or more. So then we just add whatever that amount is, and we just take that amount, which is like basically whatever, however many characters is after the underscore, we turn it to an integer, and we just add it. Else we just add it explicitly by two, because that means there's two elements. Remember, if the underscore is at the end, there's two elements. And then if none of those cases are true, obviously it's only one element. So we just add it by one. So next, we define an array by this element count. And I mean, I dynamically define this, so you'd have to clean it up afterwards. But we define an array with this element count of t objects. And so now, first let me bring in this for loop. Okay. So first we want to check, is the value, does it have an underscore in it? So that's what we first want to check. If it does, we essentially just do this right here. And so if it does have an underscore in it, we find the underscore, make sure it's not at the end. Then we get the amount again, just like above. And we basically call this array extender method, which I didn't create yet. And it returns the current position, but it extends the array and returns the pointer to the array in which it extended to basically decompress it back to its original elements, based off the type. So if the type is integer, we basically do string to integer. If it's a character, then we just use the substring to get it. And then down here, if it's if it is equal to the n, then that means that we only have two. So we explicitly do two here. We only have two elements. And I'll do the array extender in a second. Let me just bring this in. Let's see here. And so same thing. We look for the type and then we just increment by one. Exact same thing as up here. And then we just simply return this pointer, this memory address for this array. If I can see where I'm at. Okay. And so down here, let's define array extender. So first define our template. And then let's define our actual like explicit types. And so this one here is for integers. So we take um, the decompressed array pointer, the amount, the current position, because remember we're adding to this same array. So we're going to have pointers writing to this array object. So we need to know the current position and we need to keep adding on to it, and then our value. So remember up here, that's the information we're passing in here. This is our value. This is the amount up here, current position. Oh, sorry about that. And then this is our memory address. So you can see here, we just take the current position, we add to the integer, um, as long as we're less than the amount, and we just simply increment. That's why when I explicitly defined it here with the element count, that's why I did that, so that we had enough memory allocated there. Okay, so next let's grab our character definition here. Oops. And so we return an integer once again because we return the current position. Same exact thing, we just basically, now this is the character array, this is the character value. That's the same exact thing. And so that's it. And now let's implement it. So first let's include our header file. And let's bring it in. So go back up here. Oh, there we go. All right, so so I define a size explicitly. You can make this any size you want. And so basically we want to use our namespace. So we can essentially just do it like that. We define our class and we could define the constructor, which for this specific application doesn't do anything. You can see up here we have 10 values uh, explicitly that we explicitly defined. Okay, oops, okay. And so this essentially is just some house cleaning here to print it out and to show us what's happening. So this is for the integers and this is for the characters. Okay, let's run it. And so you can see here the original array size was 10. And if we look here, you can see 0, 1, 2, 2, 2, 3, 3, 4, 3, 4. So you can see here 0, 1, 2, 3, 4, 3, 4. Okay, so our new array size is 7. Well, let's see. 0 is by itself, that's a 1. 1 is by itself, that's a 1. 2 is happening 3 times, so that's a 1. So now we're at 3 elements. So you can say this is similar to a set. And so 3 happens twice, that's a 1, so that's 4. 4 happens by itself, that's 5. 3 happens by itself, that's 6. And then 4 happens by itself, that's 7. So that's right. And if you just think about it in terms of bytes, 4 times 10 is 40. 7 times 4 is 28. So we saved 12 bytes there. So it's technically compressed. And if we check the character array, you can see here B A B B B B C A F T. It sounds like a Street Fighter combo minus the T there. I don't think they have C either, but or F. Okay, never mind. But anyways, you can see B happens once, A happens once, B happens 4 times, C happens once, A happens once, F happens once, T happens once. And you can see that's what's shown here. And it says 7. Oh, wait, yep, 7. 1, 2, 3, 4, 5, 6, 7. So you can see here that both of them are outputting the correct amount. So basically, the takeaway of this video wasn't really compression, but more of the idea of creating an object inside of a library that you define um, for developers to uh, basically use for their applications, or just libraries for yourself to use to make your life easier. One thing I forgot to mention is comments. You definitely want comments. Comments are very helpful for everybody. Definitely want comments. I know with Visual Studio, you can hover over and read it. Um, See, so comments are very helpful for everybody. So you definitely want more of those. That's something I didn't put in this video, but I hope you enjoyed it. It was just something quick. You see that if I didn't obviously bring it in from here, it would take forever for me to sit here and type it all out, and it would take away from the teaching of the video, I feel like. Not this smaller algorithms that aren't as many lines, um, like those little quiz question algorithms, that I can type those ones out. But for this one here, I felt it was just a little bit bigger, so I figured I just wanted to just type that one out. Um, Also, if you notice, I have a grid algorithm on here, but it's not finished. It didn't work. It didn't give me the right area as I wanted, but I was also working on this one here. As you can see, this is a pretty big one too. So feel free to check that one out if you want as well. I hope you enjoyed it. If you have any questions, don't hesitate to leave them in the comment section. And until next time.